video, we are going to work through some mechanics, some forces and motion questions for GCSE. I will have a pause before each question so that you can try it yourself, and then we'll go through the answer. So pause the video now and try parts A and B. So part A asks you to use a calculation to help justify why a license is not needed. So what is this going on about? Well, it says any rifle that fires a pellet with an energy below 16 joules may be held without a license. And then it tells us about this paintball gun. So it fires a pellet of mass this and velocity this. And then we've got this repeated. Okay, so actually this is really not telling us anything new. So what do we need to do? We need to relate energy, mass, and velocity. So hopefully you remember that energy is half mv squared. So this is kinetic energy, is half mv squared. And then we need to put the numbers in. So a half times by mass, which is 3 times 10 to the minus 3 kilograms. And our velocity, 90. Hopefully you can spot that I forgot to put that in at first. It's 90 squared, and then we can figure out if this is correct or not. So we need to do 0.5 times 3, and then this button for standard form, minus 3 times 90 squared. This gives us 12.15 joules. And then we would say, importantly, 12.15 joules is less than 16 joules, so no license needed. I know this is a really obvious step, but it's really important to put this last one in because that is what the question is asking. What is the momentum of the pellet when it leaves the paintball gun? So we need to remember that momentum equals mass times velocity. If you write this in symbols, momentum is P. That's the one you should write down. So momentum is mass, so 3 times 10 to the minus 3 times by 90. So again, 3, this button for standard form, minus 3 times by 90 is 0.27. And our units. So they like asking this a lot. So all you need to do, you don't need to remember anything other than the standard units you remember. And actually, they've even told you in the question. So what are the units for mass? Kilograms. And we're going to multiply those units by the units for velocity, meters per second, kilogram, meters per second. Okay? So really, really straightforward. Part II. The mean force of air resistance on the pellet is 0.26 newtons. Calculate the horizontal distance travelled by the pellet after it is fired from the gun. So this actually is quite a tricky question. So we know that there is air resistance on the pellet, so it's going to slow down. And we know there's a force, and we also know its mass. So we can work out its acceleration by using this formula here. Okay, force is mass times acceleration rearranged. So the acceleration is 0.26 newtons divided by 3 times 10 to the minus 3 kilograms. That's going to give us an acceleration of 86.7 meters per second squared. We then need to really list everything that we know so we can figure out where to go from here. So the initial velocity, the starting velocity was 90 meters per second. The horizontal distance traveled by the pellet after it's fired means that eventually it's going to stop if it's slowing down. We know what the acceleration is, we've just listed it, and we're trying to work out the distance that it travels. So it's a chance to use the harder, slightly more complicated equation, which is found on your formula sheet, which is the one you use usually when you're not entirely sure what to do, and it looks a bit more complicated. It's often because there's more variables, and it's this complicated equation here. So we're trying to work out distance, so we're going to rearrange. We divide both sides by 2a, and so we end up with s is v squared minus u squared over 2a. We can put in our numbers, so v is 0 minus 90 squared over 2 times the acceleration. Now, you might notice that if I do this, I'm going to get a minus sign because it's minus 90. Well, actually, this force is slowing it down. So being 100% correct, we would actually put a little minus here because this is a deceleration. And the minus signs cancel out and we'll get a positive distance. So let's now type that in our calculator. So 90 squared over 2 times 86.7. You can see I've actually missed out the minus signs because they cancel out. And I get 46.7 meters. Is this a sensible answer? Well, it's a paintball gun. Paintball guns don't go that far. 46.7 meters is probably a sensible answer for this. Okay, question 2 is just a multiple choice question. I'll pause the video now and try this question. So, what is the mean force on the car? So, you need to use this equation, which is force is mv minus u over t, or mv minus mu over t, which, if you're doing AQA, is very much a triple equation, triple science equation. Other examples may be just the standard combined science. So now we can put in our numbers. We're going to actually use this equation here because this is just slightly shorter. 1,000 times by the change in velocity. Well, it comes to a stop, so the change in velocity is 20 over 4. So let's type that in. 1,000 times 20 over 4. Which is 5,000 newtons. So B is the answer. Okay, 2 questions now. Pause the video and answer both. Draw and label the 3 other forces acting on the fish. So we've got the forward force, which is, I guess, the force of the fish swimming. So the first one that I always label on almost any diagram ever is the weight due to gravity. Always going to be there. Now it's in water. So in water, what stops things sinking? It's obviously the force of the water pushing up. And in water, we call that upthrust. Right, that only occurs in water. And then finally, we've got the backwards force, which in water we usually refer to as drag. Water resistance might be okay, but drag is the proper name. So 2 factors that, apart from distance travelled, that would affect the speed of a toy car rolling down a ramp. So what would affect the distance travelled? Well, obviously how steep the slope is. Maybe also the amount of friction in the wheels. I'm going to put within the wheels to make it clear that I'm talking about the friction of the wheels rolling round. And maybe also the size of the car. Now, importantly, I'm going to justify this by saying how much air resistance affects it or can slow it down. Because the size of the car on its own doesn't necessarily make a difference. But if there's a really tall car like this with some wheels on, that's obviously going to experience a lot of air resistance. But if you had a really streamlined car, then that's not going to experience a lot of air resistance. Question 5. Pause the video now and try this question. So what conclusions can you make from the graph about tread depth on different surfaces? So tread depth, when you look at a car wheel, they have these grooves in them. That is known as the tread, and obviously that's to allow water to kind of flow out from the tyre so it doesn't aquaplane or kind of glide on the water. So what conclusions can we make? So obviously, as tread depth increases, what happens to the braking distance? It decreases. Now, it's obviously a 4-mark question. We've got to be really clear that it's 4 marks. So what else can we write? Well, it's not as simple as just saying if one thing increases, the other thing decreases. We can see that actually there's a bit of a shape here. There's this kind of, bent shape for both of them. So what we could say is between 1 millimeter and kind of roughly 3.5, there's a very big difference in braking distance. And then when you get to really thick tread depths, actually there isn't much of a change. So we could say something like, when the tread depth is 1 millimeter, increasing it reduces the braking distance a lot. However, increasing it above, roughly 4 or roughly kind of 3.5 makes little difference to the braking distance. We could maybe improve our answer. We could actually maybe split this into 2. We can maybe label like this one for concrete. We can maybe label this one for tarmac. I think if I was writing and if I was sitting it myself, I'd probably make extra clear that there are 2 different things here. And then the next part suggests why there will always be a minimum braking distance. So what is gonna prevent the braking distance from going to 0? Well, potentially we could write there is always a thinking distance. That may be relevant, although usually we say stopping distance is braking distance plus thinking distance. So I am not sure if this actually refers to thinking distance. The other thing that is probably worth saying is, well, actually, something else is preventing the car from stopping immediately. So there's going to be another limiting factor, such as the brakes do not apply, infinite force. So they're going to slow it down slowly, so I spelled brakes wrong. Or you could say something like the car might skid if the brakes are applied too quickly. You wouldn't be able to stop, with no distance at all, because the car would just skid. Or maybe you say something like the surface of the road is limiting the distance as well. There's a few different ideas here. Okay, final question. Pause the video now and try this question. Show the section which shows the braking distance. So we've got two sections here. We've got the bit where the speed is constant, so this is going to refer to the thinking distance, the distance you travel while thinking, and then the bit where you're slowing down is going to refer to the braking distance. So this section here is the braking distance, and this section here is the thinking distance. The stopping distance, and you can see why I did say, very carefully, that actually this one here is probably not going to be the answer, because braking distance is nothing really to do with thinking distance usually. Calculate the stopping distance. So stopping distance is the braking distance plus the thinking distance. And when we have a velocity time graph, the distance equals the area under the graph. So we need to work out the area under the graph. So you could obviously work out the area of a trapezium, or you could work out the area of the rectangle and then the area of the triangle, which is what I'm going to do. So I'm going to say the distance is the area of the rectangle, which is 35 times by 1.6 plus the area of the triangle, which is half base times height. So the base is 2, 4, that's 0.4, that is 1, 2, 3, 4, 5, that is 0.5, so 2.9 times by the height, which is 35. Which is 100, I'm just going to round it up, 107 meters. I might write the full value here if I'm worried about rounding.